Okay, let's do assignment 3, which is adding vectors. Part 1. We're going to be adding vectors. Obviously, we'll do part 2 a little later. Okay, what we're going to do today is we're going to learn how to add vector quantities. And this is purely math today. But we need to be able to add vectors together in order to do physics problems that we're going to do later on. Because a lot of quantities are vectors, things that we've already used like displacement and position, velocity, acceleration, but later on we're going to get to force and momentum and electric field. And so there are a lot of quantities that are expressed as vectors, and we're going to add them together, and we need to know how to do that. So let's take a look at this. 3 plus 4 and equals 7. Now, you learned how to do this many years ago, 10 years ago or so, when you were kindergarten or first grade. And in fact, you have 3 plus 4 and other math facts like that memorized. But this plus sign right here is actually what's called in mathematics an operator. That is, it is a symbol that tells you what to do, that gives you a procedure to follow. When you were in the first grade, this said, hey, make 3 dots, and then make 4 dots. Now, count how many dots you have. 1, 2, 3, 4, 5, 6, 7. So that's why 3 plus 4 equals 7. So, in other words, this plus sign told you what to do with these two numbers. It gave you a procedure to follow. Now, since then, you've probably neglected the procedure and you just memorize the math facts. But this is, in fact, what's going on when we add. Well, now, though, we're going to add two numbers together where it's not so easy to go 3 plus 4 and get 7. Well, I'm now going to tell you that 3 plus 4 can equal 7, yes, but I'm also going to give you a situation where 3 plus 4 will equal 5, and I will give you a situation where 3 plus 4 equals 1. Now, what the heck? Okay, don't take this home to your parents and claim there's some kind of malpractice going on here. Because really what 3 and 4 are going to be, they're going to be the magnitudes of vectors. And we're going to add vectors together. And so that is a different procedure. When you're adding vectors, it's a slightly different procedure than when you're adding quantities together that are not vectors, that are in fact what we call scalars. So let's take a look at when 3 plus 4 equals 7 when it's a vector. Well, let me give you two vectors. Vector A will look like this. It will have 1, 2, 3 units of length long. They could be centimeters or meters or whatever you want. And then vector B, let's make vector B is equal to 4 units. So there's vector B. So this is 4 units long, and this is 3 units long. Now, when you add vectors together, here's what you do. Here's what the operator is telling you to do with those two vectors. When you have A plus B. This plus sign now means something different than it did before. It says, okay, here's what you're going to do. You're going to take vector A, and then you're going to take vector B and hook it up to vector A so that they are head to tail, so that the arrow or the head of A is hooked up to the tail of B. So the arrow part, I'm going to call that the head of the vector, And where the vector starts, that's going to be the tail. And it's basically saying, take vector A. So I'm going to do this. I'm going to rewrite vector A. 1, 2, 3. There's vector A. And I'm going to hook up vector B. I'm going to hook the tail of vector B up to the head of vector A. So I'm going to move this over here. And here's vector B, where it's 1, 2, 3, 4 units long. I have now added the two vectors together. I have hooked them up, the head of A to the tail of B. Now, the result of this is called the resultant vector. And it starts where A starts, and it ends where B ends. And I'm going to call this vector R. So I'm going to say, in fact, I'm going to say R is equal to adding vector A and B together. And we get another vector. And now, what is the magnitude of this vector? 1, 2, 3, 4, 5, 6, 7. It's equal to 7. Now, the reason why A plus A, which was 3, and B, which was 4, add up to 7 is because what's true about vector A and B? They are in the same direction. So if you have two vectors, A and B, that are in the same direction, yeah, you could just add their magnitudes together. But what if vector A and B are in different directions? What if we have this situation? Let's say A is the same as we had before. So 1, 2, 3 units long. But now vector B is going to be straight up and down. So 1, 2, 3, 4 units long. Now if I go A plus B, I'm going to follow that same procedure. I'm going to hook up vector A and vector B head to tail. So here's vector A, 1, 2, 3. And here's vector B, 1, 2, 3, 4 units long. And here's my result. It's different than what we had before. Remember, the result of adding two vectors is to start with the tail of vector A and end with the head of vector B, and it looks like that. I'm sorry, this is B right here, and this is our resultant vector. And notice, in this case, that vector B is 1, 2, 3, 4, 5 units long. Well, they make a triangle, don't they? A 3, 4, 5 triangle. So here's an example of how 3 plus 4 equals 5. Finally, if vector A looks like this, 1, 2, 3, but now vector B looks like this, but now it's in the opposite direction. When I go A plus B, well, we follow that same procedure. We rewrite vector A, 1, 2, 3 units long. Then we put the tail of vector B where the head of vector A is, and then I draw vector B. And I don't want to draw one on top of the other because you can't see, but 1, 2, 3, 4 units long. And you can see that if we start where A started and end where B ends, we get a vector R that's equal to 1. Of course, it's in the negative x direction. So this is how you add vectors together. You hook them up head to tail, and see what you get. Okay, to continue. Again, this plus sign, when it's between two vectors like this, it's telling you to follow a procedure, do something specific. Hook up vector A and vector B head to tail. If they're in the same direction, here's A and B. If they're perpendicular to each other, A plus B. If they are in opposite directions, you go A plus B. And the result of all of this is to start where A started and end where B ends. And so here you get 7, here you get 5, and here you get 1. Okay. Now what we're going to do is we're going to do this mathematically. How would you add these together, more analytically? This is a great graphical approach that I've shown you here, but now we want to do it a little bit more mathematically. So let me zoom in a little bit. And we're just going to do our 3 examples that we did before. The first example is when A and B are in the same direction. So if I take A plus B for our first example, you know what I'm going to do? When I do this mathematically, I don't write it like this. I go A plus B. I line it up in columns like this because it makes it a little bit easier to solve the problem. Then, now let's take a look at vector A and vector B. What I do now is I write down the 2 vectors in rectangular coordinates with the x coordinate first and the y coordinate second. So let's take a look at vector A. What is vector A? Well, it's how far in the x direction? 3. And how far is vector A in the y direction?
7.
It is 0 in the y direction. Now let's take a look at B for our first example. How far in the x direction? 4. And how far in the y direction? 0. And now I could say, hey, in the x direction, my resultant vector, or the vector I get from adding these 2 vectors, is I just go 3 plus 4 equals 7, and 0 plus 0 is 0. And this is my resultant vector in rectangular coordinates. Now, I want to write down my answer in polar coordinates. On the homework, all your answers, all the resultant vectors, have to be in polar coordinates, which gives me a magnitude and a direction. Well, what is the magnitude of this vector? How long is this vector right here? Well, it's obviously 7. So if I write vector r in polar coordinates, then it's going to be 7 meters or whatever we're using, 7 units long. What is the angle here, though? Remember, the polar coordinates, it's r and theta. What's the angle? Now let's take a look at the vector again. What's the angle of this on an xy plane? It's 0. 0 degrees. So by inspection, you could just write the answer like this. Easy. Okay, but if you really wanted to be rigorous about it, if you want to get really ridiculous, you can say, all right, well, r is equal to the square root of the x component squared plus the y component squared, take the square root. Right? Pythagorean theorem. Well, what do you get? 7 squared is 49 plus 0. Square root of 49 is 7. Then you can take the inverse tangent of the y value over the x value. Well, what's the inverse tangent of 0? 0 degrees. So So that's our theta. Okay, so you can go through all this, but look at the picture. You don't need to do all this math. Look at the picture. You can see that it has a magnitude of 7 and an angle of 0 degrees. This is the answer to A plus B for our first example. Now for our second example, it gets a little bit more complicated. Here we have A plus B, and so if I'm going to write this example in rectangular coordinates, well, what is A? Well, A, once again, if I look at it, it's 3 units long in the x direction and 0 in the y direction. And then, but look at vector B now. Vector B, if I look at vector B, it has no x component. So in the x direction, B is 0, but in the y direction, it's 4. Whoops. Keep me on camera there. So now I just add them together, like I did before. 3 plus 0 is 3. 0 plus 4 is 4. And that's my answer in rectangular coordinates. Now, if I want to get this in polar coordinates, well, I'm just going to say r is equal to the square root of the x component squared plus the y component squared. Well, you know this. 9 plus 16 is 25. Take the square root of 25, you get 5. Now, theta is the inverse tangent of the y value over the x value. Do I need to add 180 degrees to my answer? No. The x value is positive. And when you plug that in your calculator, you get 53.1 degrees. So I can say vector r in polar coordinates is 5 at 53.1 degrees. So I lied at the beginning a little bit when I said that 3 plus 4 equals 5. The magnitude of adding these vectors is 5, but you have to include the direction to get our full answer. This is what you're going to be doing in the homework. Finally, let's do our last example. A is, and I'll have to go way up here. If you look at A is 3 meters or 3 whatever units in the x direction and 0 in the y, plus B. Well, let's take a look at B. Look at B. It's 1, 2, 3, 4 units long, but it's in the negative x direction. So this is going to be negative 4 and 0. So this is going to be negative 1 in the x and 0 in the y. And that's my result. Now, if I want to put this in polar coordinates, well, the square root of the x component squared plus the y component squared, it's negative 1 squared is 1, plus 0, take the square root of 1 is 1. So that's my magnitude, is 1. But what is my direction? Well, look at the picture. The best way to do it is to look at the picture. If A is over like this and B is over like that, R is at what angle compared to our positive x-axis? Well, that would be 180 degrees. Does that make sense to everybody? That's 180 degrees. It's to the left. And there's our answer. Okay, here's part 3. Here's the worksheet right here. And I'll put it, I'm going to hand this out in just a minute. But if you're watching the video, you can just freeze frame and copy it or something. Number one, let me finish this problem, and then those of you going to CART, you can come on up here and get the worksheets. Number one, what's given? Well, if you read the directions, you need to draw a picture of it and also solve it mathematically like we just did. But look at this. Number one, it says 4 meters to the east. Well, what does that mean? A is 4 meters to the east. Well, you have to recognize this, that the compass points that we're going to be using, north, south, east, and west. I mean, this is a standard way of doing it on a map. So the east is really the positive x direction. North is the positive y. West is the negative x direction, and south the negative y direction. So when I say A is 4 meters to the east, I can write it in rectangular coordinates. 4 meters to the east is just 4 meters in the positive x and 0 meters in the y direction. And then let's look at vector B. What direction is north? Well, north is straight up. So B is 0 meters. You don't have to put meters with 0. In the x direction, and it's positive 7 meters in the y. And so we want to find the resultant vector. Well, we want to draw a picture of A plus B. And then we want the resultant vector. What is it? Magnitude and direction. I want it in polar coordinates. Well, let's solve it. For A, I'm just going to draw, 1, 2, 3, 4. There's vector A. And then B is 7. It's going to be a little bit longer. 1, 2, 3, 4, 5, 6, 7. And so my resultant starts where A starts and ends where B ends. There's my resultant vector. Now, let's do it mathematically. Maybe I could, let me zoom out a little bit. So here's B. So R is A plus B equals R. Now A is 4 meters, 0 meters. And B is 0 meters, 7 meters. So when I add them, we're going to move 4 meters in the x direction and 7 meters in the y direction. Well, now this is my answer in rectangular coordinates, but I want you to put them in polar coordinates. So R will be equal to the square root of 4 squared plus 7 squared. This will be in meters. And when you do the math, you get 8.1 meters. And then theta is the inverse tangent of the y value over the x value. Do I have to add 180 degrees to my answer? No, because since I'm in the first quadrant here, because both of these are positive, I don't need to add 180 degrees. My calculator gives me the right angle, or the correct angle, which turns out to be 60.3 degrees. So I can say that vector r is equal to 8.1 meters. That's my magnitude. 60.3 degrees. That's my direction. So that's the answer to number 1. So what I'd like you to do now is as much of this worksheet as possible before the bell rings.